Hello, welcome to Chapter 8, Section 2, Strength of Acids and Bases. There's just really two main concepts to this section, and we're going to make it pretty nice for you. I will give you the table on page 292 that talks about strong acids and weak acids, and so we're not going to use any other acids other than those, so that should be a nice helpful table that you can use for the test. The key concept for this whole section is that strong acids completely ionize, so 100% in aqueous solution. And so we see, just like we saw with electrolytes, where we have the single arrow, we have a single arrow for strong acids because they completely ionize into their components. Okay, and so we looked at earlier that an acid is a proton donor. Okay, so it loses a hydrogen ion. So here's our acid, here's our base, just a reminder. And our base accepts the proton, and so it is going to gain a hydrogen and become hydronium. And so the identification of an acid in water is the fact that it produces this hydronium ion in solution. Okay, so that's how we got this reaction equation. But the key is that we have a single arrow here, and I'm going to circle it here. Single reaction arrow, meaning that 100% of HCl in water ionizes into H3O plus and Cl minus. Okay, for weak acids, just like weak electrolytes, we have this equilibrium arrow. So we produce some ions, but then the reverse reaction, so some of the forward reactions. So here's our carbonic acid, and it loses a proton to give us the conjugate base. And water here is our base that gains a proton to give us our conjugate acid, Ca for conjugate acid, Cb for conjugate base. However, it's weak, and so the ions that produce will also recombine and form back the product. So it's a reversible reaction. You have ions being produced, then you also have the ions reacting together and shifting their equilibrium. This is an equilibrium arrow, shifting it back to the left over here. Okay, so in water, the dissolved molecules of a strong acid completely dissociate 100%, and so this just shows you a graph of this. So 100% of the ions are formed from your initial strong acid. So if you look at your list, you've got a list of strong acids there for you. So you have nitric acid, sulfuric acid, hydrochloric acid, perchloric acid. All of those will 100% ionize. That is the key to this section, that strong acids 100% ionize and weak acids do not. It's going to be the same for bases. So here's some of the strong acids. So this graph, or this does not include the weak acids. Okay, this first part up here is the strong. So here's the strong. In weak acids, only a few molecules dissociate to the ions. Okay, and so what happens is we have this, once again, this reversible reaction. And so if we look here at our weak acids, we're going to get a mixture over here. So we're going to get some ions, a few. So our ions here is in red, and blue is would be our conjugate base. But then you have majority of these are molecules. So they're HA. They're not ions. They're the acid that you originally started with. So here it would be the carbonic acid. Okay, so here's an example of the weak acids. A list of these. Once again, these will be given to you on the exam. And other thing that's unique, your book doesn't go into it a whole lot, but for the conjugate base of a weak acid is going to be strong. So they have an inverse relationship. So if you have a weak acid, so this is the list of weak acids, the conjugate base is going to be strong. Okay, if you have a strong acid, the conjugate base will be weak. Okay, but for a weak acid, its conjugate base is going to be strong. And this is showing you that you increase in acidity. So the hydronium ion is the most acidic of this weak acid list, and this would be your least acidic. Okay, so this just shows you an example. This looks similar to what we would have in a lab. So you have, in most of our, may not be glass bottles, but if you have HCl, it 100% ionizes. And so you see here you have ions. So this is your chloride ion in the green. This would be the chloride, and then this would be your hydronium. So it's 100%. So you see all these ions, meaning positive and negative charge. Okay, but if we take a weak acid, okay, and we place it in water, and it's 1 molar as well, we see here that we don't have very much charge. We've only got 2, and the rest are just molecules, or neutral molecules. So it does not completely ionize. That's what a solution would look like on a molecular level. Okay, so this is just the comparison. So putting the two tables together, okay, this is the table that will be given on the exam. Okay, you still want to become familiar with, hydrochloric acid is a strong acid, sulfuric acid is a strong acid, water is a weak acid, obviously. It can act as an acid or a base. Acetic acid is another good one. That's in vinegar. Okay, but you want to become familiar, but you will be given this list, so you will know whether it's a strong or a weak acid. As for bases, there's not really a list that I will give you because these are a little bit easier. Basically, when you form metals from group 1 or group 2 on the periodic table with hydroxide, so this includes lithium, sodium, potassium, calcium, they will dissociate completely in water to produce the ion of the metal and hydroxide. Okay, and so these are strong bases. So your group 1 and group 2 metals formed with hydroxide are strong bases. So if it's in group 1, if the metal's in group 1 or group 2, you consider this to be a strong base. And these are examples of strong bases that are in a lot of our cleaning materials that we have at home. Okay, so if we go through our list, HBr, if we look on we have a list for acids, so we know that HBr is a strong acid. Okay. You have to be careful with B because there's nitric acid and then there's nitrous acid. Okay, when it has HNO2, it's nitrous acid, which is a weak acid. So we're going to do all the acids first and come back to the bases. Okay, we have sulfuric acid is our next acid, and it is strong. So it is in the strong, H2SO4 is in the strong list. If we look at our bases, which we can identify by the hydroxide, we have sodium hydroxide. Sodium is in group 1, so we know it is strong. Okay. Next we have copper hydroxide. Copper is not a group 1 or 2 metal. It's actually a transition metal, and so we consider this to be a weak base. A weak base, a strong base. So really you just got to become familiar with, recognizing an acid and a base. Our acids are going to have protons, our bases or hydrogens. Our bases are going to have hydroxides, but some of them can be a little tricky at times. But you will be given, your table, so you can look at that and be able to recognize if it's a weak or a strong acid. And then for bases, if it's a group 1 or 2 metal bonded with hydroxide, then it's going to be a strong base. Okay, and remember also that this is a weak base. This is another example of a weak base. This concludes the video for section 8.2. Thank you.